Algebra Honors, Unit 6 is on exponents and radicals. This is day 9, and we're going to talk about solving radical equations. So that's solving equations that have some sort of a radical in them. So our list of steps. We want to isolate the radical on one side of the equation, and then we're going to raise both sides to the nth root to eliminate that radical symbol. So if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. If it's a fifth root, we're going to raise each side to the power of 5. We're not going to have anything more than square roots and cube roots in this class, though. All right, so once we raise both sides to the nth root to get rid of the radical symbol, then we're just going to solve so that we solve for whatever our variable is. The very last step you want is you want to plug in whatever answer you got or whatever answers you got, and make sure that if you plug them back into the original equation, they make sense. So let's take a look at this. We're going to do the square root of x equals 13. So right now, in order to undo square root, I have to square, right? So I'm going to square this side, which means I have to square that side, because math is always fair. So square undoes square root, just like we talked about previously. Only we were going in the other direction before. Square undoes square root, and so I'm just left with x, and that equals 169. So if I plug in 169 and take the square root, sure enough, when I check it, the square root of 169 really is 13. Check. Okay, so if I look at number 2, I need to isolate that radical. So my radical is this statement, square root of x plus 5, right? So I'm going to subtract 7 from each side, and I now have square root of x plus 5 equals 12 minus 7, which is 5. I'm going to square each side to undo the square root. Square, undo square root, so I just have x plus 5 left, and that equals 25. And now I subtract 5, and I get x equals 20. So I want to make sure that that makes sense. I'm going to check it. So the square root of 20 plus 5, that's the square root of 25, right? Plus 7 equals 12. I'm checking to see. 5 plus 7 equals 12. Check, that's true. All right, number 4. Let's see. We want to get that radical expression all by itself, and so I'm going to subtract 4. So I have the square root of x plus 1 equals 10. Undo square root by squaring, and so we're going to undo the square root by squaring, and I have x plus 1 equals 100. Subtract 1 from each side, I get x equals 99. Let's just make sure. 4 plus the square root of 99 plus 1 equals 14. This is our question. 4 plus the square root of 100 equals 14. And sure enough, 4 plus 10 equals 14. So check, our answer worked. Okay, so we're trying to find a value for any one of our variables. All right, this guy. I'm subtracting 2 from the radical expression, so to undo that, I'm going to add 2 to each side. So I have square root of x minus 3 equals 6. This is a square root, so I'm going to undo that by squaring everything. Square undoes square root, so I have x minus 3 equals 36. Add 3 to each side, x must equal 39. If I want to check it, I have the square root of 39 minus 3 minus 2 equals 4. So that is the square root of 36 minus 2 equals 4. 6 minus 2 equals 4. True. Check. Okay. So right now you're thinking, why do I have to check all the answers? Well, we're getting to it. Sometimes when you solve something, you end up with something called an extraneous solution. So it's a solution that you got to mathematically, but when you plug it back in, you'll see that it doesn't make sense. This is partly because when we're squaring both sides of an equation, sometimes we just end up with some unintended consequences. So let's take a look. If I want to know the square root of x equals negative 5, if I solve that the way we've been solving all of the ones that we just did, I'm going to square each side, right? So I would square the square root of x, those cancel, and then I square negative 5. Negative 5 times negative 5 is positive 25. So far, so good. Okay, but if I check it, I'm going to plug that back in. So I'm going to say square root of 25 equals negative 5. Well, this doesn't make sense because square root of 25 for us right now, we're only asking for the principal root, right? I just want the positive root, not the negative root. So since that doesn't make sense for us, we're going to say x equals 25 is actually not a solution. It's not a solution. So I would say no solution here. Okay? Or I would say that the solution I got was an extraneous solution. Right? Sometimes when we did absolute value equations, we ended up with extraneous solutions too. We got there mathematically, but then when we plugged them in, it didn't quite work. Okay, so we're going to check out numbers 5 and 6 on your page here. So I'm going to say the square root of k plus 1. I'm going to undo the square root by squaring everything, and so I get k plus 1 equals negative 1 times negative 1 is positive 1, so k equals 0. So if I put that in, I get the square root of 0 plus 1 equals negative 1. The square root of 1 equals negative 1. 1 equals negative 1, and that's not true, right? Again, it's because we want the principal root. We have not asked for the positive and negative roots of anything. We just want the principal root, which is the positive root of a square root. All right, so over here, negative 3 equals the square root of x minus 1. So I'm going to square each side. Negative 3 squared equals the square root of x minus 1, all squared. So negative 3 times negative 3 is positive 9. This equals square and square root cancel out. So it equals x. Oopsie, sorry, that's minus 1. Hold on, pause. Magic. 9 equals x minus 1. Add 1 to each side. 10 equals x. So I'm going to check it by plugging it back in. Negative 3 equals the square root of 10 minus 1. 10 minus 1. Negative 3 equals the square root of 9. Negative 3 equals 3. Because we're looking for the positive root, right? And that is not true. So these are our extraneous solutions. So we don't have a solution, right? We're going to say no solution. If you take the trouble of writing down extraneous solution, then I'll give you credit, of course. I don't know about your other teachers, though, if you're not one of my students. Okay. Practice here. So try these practice problems, and then either try them one at a time and pause the video, or try a bunch of them, pause the video, try a bunch of them, and then come back and check your work. I'm going to square each side. So I get x equals 81. If I check it, the square root of 81 is positive 9. 2. Square each side. So I get m plus 5 equals 4. M equals negative 1. If I plug that in, negative 1 plus 5 is 4. And the square root of positive 4 is positive 2, so that works. Square each side here. I'm going to get 3 equals 3 squared equals 35 minus 2w, square root, all squared. So 9 equals, boop, boop, those cancel, 35 minus 2w. Subtract 35 from each side, so I get negative 26 equals negative 2w. Divide by negative 2, I get 13 equals w. I'll just do a quick check up here. So I'm saying that 3 equals the square root of 35 minus 26. I'm saying 13 is positive, 13 is w, so minus 26, that works. 3 equals the square root of 35 minus 26 is 9, and 3 equals 3. Yay, that worked. Okay. 4. I want to get that radical all by itself, so the first thing I'm going to do is add 7 to each side. So I have the square root of x equals negative 6 plus 7, which is 1. Square root of x equals 1. Square both sides, and I get x equals 1. If I plug it back in, square root of 1 is 1. 1 minus 7 is negative 6. That seems to work. All right. Here I have negative 50 equals negative 10 times the square root of n. I'm trying to get that radical all by itself, so I'm going to undo that multiplied by negative 10 thing. So now I have 1 square root of n over here. Negative 50 over negative 10 is positive 5 equals the square root of n. Square both sides. like so, and I get 25 equals, boop, boop, and let's just plug it in and make sure. If I check it, it's negative 50 equals negative 10 times the square root of 25. Negative 50 equals negative 10 times 5, and negative 50 equals negative 50. So check. All right, make sure you're checking these on doing these on your own and then coming back to check your work, right? Square each side. Okay, square undoes square root, so I have x plus 2 equals 9. So a lot of times when I have negatives that I'm squaring, I'm going to be a little skeptical and wonder if I have an extraneous solution. So x equals 7 here. So let's plug that in. The square root of 7 plus 2 equals negative 3. Square root of 9 equals negative 3. 3 equals negative 3. Nope, not true. So that's extraneous, so I would just say no solution here. I did get a solution mathematically, but it didn't make sense. All right, let's divide each side by negative 8 here. And so I get square root of 2x plus 3 equals 5. And now I'm going to square each side. So I get 2x plus 3 equals 25. 2x equals 25 minus 3 is 22. X equals 11. I will plug it back in. So I get the square root of 22 plus 3, all in the square root bar, equals negative 40. Oops, I'm missing the negative 8. Sorry, do you see that negative 8 there? I just didn't see it. Negative 8 times the square root of 25 equals negative 40. Negative 8 times 5 equals negative 40. And that's true. I'm all happy. So even though my stuff equaled a negative number and I was a little worried and a little skeptical, it turns out everybody's fine and happy. So x equals 11 is the answer here. I didn't have anything extraneous. It made sense. All right. Add 11 to each side, so I have 2 times the square root of x minus 4 equals 8. Divide each side by 2. I have square root of x minus 4 equals 4. Square both sides, so I have x minus 4 equals 16, and that means x equals 20. Okay, if I plug it in, 2 times the square root of 20 minus 4 is 16, and that's minus 11 equals negative 3. All right, so let's see what we've got left. We're going to do problems 9 and 10. 10 says challenge, so we're going to see what we do. For number 9, I want to isolate that radical, so of course I'm going to subtract 21 from each side. So I have 12 equals the square root of 8k. Let's make sure 33 minus 21 really is 12, right? Yeah. Okay, square each side. So I get 144 equals 8k. That squared undoes the square root. That's what we're doing. If I divide each side by 8, I'm going to get 18. So I have 18 equals k. So just for kicks, 33 equals 8 times 18 under the radical plus 21. So 33 equals 8 times 8 is 64. 8 plus 6 is 15. 154. Square root, that doesn't seem right. We're going to have to figure out what I've done there. Hold on. How about 144? That makes a whole lot more sense. Sorry. 8 times 18 is 144. 64, and then 8 plus 6 is 14. Okay, so now I have 33 equals 12 plus 21. Oof, 21. And that's true. 33 equals 33. So as long as I multiply 8 times 18 properly, it's all good. Okay, down here in the challenge, we're going to isolate our radicals, but I have a radical on each side. So I know how to get rid of a radical, right? I'm going to square each side. Let's see what happens here. So square undoes the square root. Square undoes the square root. I have r equals 42 minus 2r. And of course I know how to solve this. I've just got variables on both sides, so I need to get both variables to the same side. So I'll add 2r. Add 2r, poof. 3 r's equals 42, and r equals 14. Well, let's just see if this makes any sense. Okay, if I plug it back in, I'm going to get the square root of 14 equals the square root of 42 minus 2 times 14. Okay, so if I'm solving that, the square root of 14 equals the square root of 42 minus 28. Square root of 14 equals the square root of 42 minus 28 really is 14. So square root of 14 equals the square root of 14. That is a true statement, and I don't even have to try to simplify that or anything, because I can leave it right there because I can see that I have a true statement. So my answer really should be r equals 14. Great, thank you for watching.